Confidence intervals in every single clinical or medical study or paper that you read will be reported, and they're very, very important for some very good reasons. So confidence intervals are usually at the plus or minus 1.6 level. So when you go back to this distribution diagram, so when we're looking at 1.96 from a z table, we're ideally looking at about 5% error, which means if you're looking at a two-tailed study, it's 2.5% on each tail. So 95% of your data points fall in this region. Confidence intervals, particularly when it comes to ratios like the odds ratio and relative risk, can be really useful because if the confidence interval includes 1, then that means that the statistic is not significant. You can often use confidence intervals to determine the difference between two groups. So if you have two groups that are being studied, let's say there's group 1, that is an intervention group for a study intervention that you've done, and then the group 2 is a non-intervention group or the control group. So you have mean values for each of these two groups. When you're trying to compare the mean values, you can use the confidence interval as a point estimate to do so. Now we come to something that is known as the p-value. So the p-value is basically the probability that given that the null hypothesis is true, your observations are due to chance alone. We want to minimize the observations due to chance because that introduces error. So we're willing to take the chance that we are wrong a certain amount of times. So the p-value is usually established at less than 0.05. What this really means is that we're willing to take a chance that there is a 5% error in the study. Or in other words, if I repeated the study every single time, I would be wrong 5 times out of 100. So if I did 100 studies, then I would be wrong 5 times out of 100, but 95 times I would be right. So when you're thinking about p-values, whichever statistic that it is that you're measuring, so whichever variable it may be, if you're looking at blood pressure comparisons between two groups, if you're looking at mean A1C levels across two groups, a treatment group and a control group, for example, you want your test variable to be less than 0.05 to be significant. 0.05 is really a rule of thumb. So if we are willing to accept a much lesser margin of error, then we could also go down to as little as 0.001. So this would again make the study very, very tight. Remember that to do this, you would need a very, very large sample size, which I will explain in a little bit.